Many of us find organic chemistry very tough and think the subject is all about memorization. I'm working on creating a series of YouTube videos that will help learn organic chemistry step by step and with the requirement of less memorization. I hope these videos will make organic chemistry easy. The first video is for the students who are going to take the organic chemistry for the first time. The students could be a high school student or a college student. The video will help understand the very basics of organic chemistry. So let's begin. Before we deep dive into the subject of organic chemistry, the first question we need to ask is, what is organic chemistry? How the name organic compound was originated? What exactly are these organic compounds? In the 17th century, scientists noticed that living organisms have certain unique compounds that are totally absent in non-living things. For example, compounds like proteins and sugars are found only in the living organism and are totally absent in non-living organism. Scientists call this unique compound, which are present only in the living organism, as organic compound. So in the olden days, by definition, organic compound is nothing but the compounds of living things. The next thing scientists did was they tried to make this compound in the lab, but they were not successful. So they wonder why they are unable to make this organic compound in the lab. So they had the notion that the living organism might have a special force called vital force or vitalism. And because of this, the scientists are unable to make the compound in the lab, and the living organisms are able to make because they had this special force called vital force. But in the year 1828, a German scientist by name Friedrich Holler performed an experiment. He heated ammonium cyanide, which is an inorganic compound, and converted it into urea. Urea is an organic compound. So with the synthesis of urea from ammonium cyanide, the first organic compound was synthesized in the lab. With the success of the synthesis of this organic compound in the lab, the myth or the belief of vital force or vitalism is totally destroyed or shattered, which means Frederick proved that we do not need a special force to create organic compound or to make organic compound in the lab. After this, scientists started making many different organic compounds in the lab. The next question we need to ask is, okay, now we can make the organic compounds in the lab. Organic compounds are found in the living organism. So what should be the correct definition of organic compound? Because we cannot call organic compound as the compounds of living things, because we can make it even in the lab. One thing scientists noticed about the organic compound is all the organic compound essentially contain carbon, which means if there is no carbon, there is no organic compound. So the new definition of organic compound is the compound of carbon. So today, the modern definition of organic compound is defined as the compounds of carbon. In other words, organic compound is the compound of carbon. The next question we need to ask is, okay, if organic compounds are the compounds of carbon, why we need to study as a separate branch of chemistry called organic chemistry? Why can't we include as one or two chapters of physical or inorganic chemistry? The reason is organic compound is huge in number. So far, about 20 millions of organic compounds has been discovered. And when we compare the number of compounds of carbon with that of the compounds of all other elements put together, it is found that the compounds of carbon is much more in number than the compounds of all other elements. So this is the reason why we are studying organic chemistry as a separate branch of chemistry. The next question we need to ask is, why organic compounds are so huge in number? This is because carbon has a special property called catenation. Then we need to know what is catenation. Catenation is a property of an element where an atom of one element can form a bond with another atom of the same element to form compounds of different chain lengths or rings. For example, carbon has the catenation property through which one carbon can join with the other carbon to form the carbon compound of different chain length, or they can also form the cyclic compound. This unique property of catenation makes carbon to form millions of different types of compounds. This organic compound can be classified into two further types. One is the open chain compound and the other one is the closed chain compound. Closed chain compound are also called the cyclic compound. And open chain, they are called open chain because the first and the last carbon are not connected. It can be described like a broken necklace. This open chain compound can be of two types. One is the straight chain where there is no branching. The other one is branched open chain compound where you will see different branches in the carbon compound. Cyclic compound can be of different carbon atoms in the ring. This is a cyclic compound that contains 3 carbon, and this is the cyclic compound that contains 4 carbon atoms. We can have cyclic compound containing different number of carbon atoms. Now, the next question we need to ask is, okay, we know that organic compound is huge in number, and we need to dedicate a separate branch of chemistry to study the organic compounds. But how we are going to study? Are we going to pick up an individual organic compounds and try to find out their properties? If we do so, it may take many thousands of years for us to complete the study of individual organic compound. The best way to study the organic compound is through the classification. An organic compound can be broadly classified into as hydrocarbon and derivatives of hydrocarbon. So organic compound can be broadly categorized as hydrocarbon and derivatives of hydrocarbon. Hydrocarbon means they are the organic compound that contain only carbon and hydrogen, and hence the name hydrocarbon. On the other hand, derivatives of hydrocarbon means they are derived from hydrocarbon. And these derivatives of hydrocarbon, besides carbon and hydrogen, also contain other elements like oxygen, nitrogen, phosphorus, halogen, sulfur, and others. Examples of derivatives of hydrocarbon are methanol, chloromethane, ether. Don't worry at the time being how we go to the name of the derivatives of hydrocarbon and what are their structures. We'll be learning this into the different series or in the next series of our organic YouTube videos. For the time being, we'll focus on the hydrocarbon. As I mentioned, hydrocarbon are the compound, organic compound that contains only carbon and hydrogen. This hydrocarbon can be further classified into 3 types. One is the alkane, the other is the alkene, and the third one is alkyne. Please pay attention after the word called alk. In alkane, we have ANE. This ANE indicates that alkane are the hydrocarbon that has only carbon-carbon single bond. We do not see any multiple bonds between the carbon atom in the alkane. Alkene, in ending ENE, that means it is a hydrocarbon that has at least one carbon-carbon double bond in the structure. Alkyne, the ending with the YNE, the YNE tells you that is the hydrocarbon that has at least one carbon-carbon triple bond. In summary, alkane is a hydrocarbon that has only carbon-carbon single bond in the structure. Alkene is a hydrocarbon that has at least one carbon-carbon double bond. And alkyne is the hydrocarbon that has at least one carbon-carbon triple bond. For the time being, we will not talk about the derivatives of hydrocarbon. This we will talk into the next series of videos. But we will concentrate on the study of hydrocarbon. We will try to know what is alkane and how to write the structures and name the alkane. Similarly, we will dedicate our time on the alkene, and then we'll talk about the alkyne. So the first thing we are going to talk is about the alkane. So what exactly are the alkane? As I mentioned, alkane are the hydrocarbon that contains only carbon-carbon single bond in the structures. There are thousands of alkane. So how are we going to study alkane? To learn more about the alkane, we need to have a general formula, and the general formula to represent alkane is CnH2n plus 2, where N is a natural number and starts with 1, 2, 3, and N represents the number of carbon atoms present in the alkane. But let's talk in detail about the alkane. As I mentioned, alkane is a hydrocarbon that contains carbon-carbon single bond in the structure. And the general formula to represent alkane is CnH2n plus 2, where N is a natural number and N can start with 1, 2, 3, and so forth. So N will tell you how many carbon are there in the particular alkane. So there can be many members of alkane. So first we can start an alkane that has N equals to 1. So when I put the formula, change the formula, or in place of N when I put 1, the formula becomes Cn C1H, so 2 times 1 is 2, plus 2 is 4. So the formula is CH4. Thus, the first member of alkane is a formula with the CH4. The question we need to ask is why methane or this CH4 has 4 hydrogen. Why the formula is CnH2n plus 2? That's because carbon has tetravalency, or carbon valency is 4. In other words, carbon wants to form 4 bonds. That's why when we say carbon is connected with another carbon, one bond, another carbon, another bond, and this is the 4th bond. So the first member of alkane, which has the formula of CH4, is bonded to 4 hydrogen through the 4 bonds because the valency of carbon is 4. It wants to form 4 bonds. The next question now we need to ask is how I'm going to name this CH4. I just cannot call it alkane. Alkane is the general name. To name this based on the number of carbon atoms, alk tells you how many carbon atoms are there in that particular alkane. So based on the carbon atom, I'm going to change the name alk with some other prefix. If you see in the table, I have, if there's one carbon, the name alk will change to meth, and the compound will be called as methane. Now if the alkane has two carbon atoms, the alk will change to eth, and the full name for that compound containing two carbon atoms will be ethane. Similarly, if the carbon has four carbon atoms, the name will become pent, and the full name is pentane. So the alk will tell you how many carbons are there in that alkane, and based on the carbon atom, the name could be either prop, bute, pent, hex, hept, oct, non, or decane. Thus, the name for the compound CH4 or for the alkane is CH4 is methane. It's called methane because it contains one carbon atom. Now let's go to the next member of the alkane. To go to the next member of the alkane, now let's N equals to 2 is the second member of the alkane. Now the general formula is, as we have written, CnH2n plus 2. So in place of N, we are going to substitute 2. So it becomes C2. So 2 times 2 is 4. 4 plus 2 is 6. So the second member of alkane has the formula C2H6. Now how I'm going to draw the structure? To draw the structure of any organic compound, we need to first connect one carbon to the next carbon. That means now I will see how many carbons I have. I have 2 carbon. So connect these 2 carbon atoms. Then remember, carbon is supposed to have 4 valency. Now this carbon already has 1 bond. So it needs 3 more bonds. So that bonds will be fulfilled by the hydrogen. So 1 hydrogen here, 2 bond for this carbon. This is 3 bond. This is the 4 bond. For the next carbon, again it already has 1 bond. It needs 3 more bonds because altogether carbon needs 4 bond. So 2 bond, 3 bond, 4 bond. So this is the structure of second member of alkane. We call this as expanded structure. Why we call expanded structure is because we are indicating how each hydrogen is bonded to the carbon and how carbon are interconnected. Now we can write the condensed structure for this molecule, condensed structure. To write the condensed structure, you start from the left side. This carbon has 3 hydrogen, 1, 2, 3. So I write H3. After the hydrogen comes the carbon. So write carbon. This carbon is connected to this, to the bond, to the other carbon. This carbon has 3 hydrogen. So this is the condensed structure. Now how I'm going to name this alkane? Now I see that it has 2 carbon atoms. So based on our table, if there are 2 carbon atoms, we call this as eth. So the name will become eth plus n, ethane. Now let us go to the third member of the alkane by substituting the formula. So that the third member, as we know, the general formula is CnH2n plus 2. Now n equals 3. So substitute the value of n into the general formula. It will become C3H. So 2 times 3 is 6. 6 plus 2 is 8. So the third member is C3H8. So what is this expanded structure? The expanded structure you can write by, first you have to connect all the 3 carbon atoms, carbon, carbon, carbon. So I connected all the 3 carbon through the bond, and there are 3 carbon atoms. So each carbon atom is connected to the other carbon atom. Now this carbon, let's name or position this carbon atom. So this is carbon number 1, this is carbon number 2, this is carbon number 3. Carbon number 1 has already 1 single bond. It needs 3 more. So 3 hydrogen for this carbon atom. But for the middle carbon, this carbon is corner carbon. But middle carbon has already 2 bonds, so we need only 2 more bonds, because altogether carbon needs 4 bonds. So 2 bonds over here, hydrogen, and this carbon 3. The third carbon is corner carbon. Always the corner carbon already has only 1 bond, so it needs 3 more hydrogen. So altogether, each carbon here has 4 bonds. This is the expanded structure of the alkane with the general formula C3H8. Now, how to write the condensed structure? To write the condensed structure, you start from the left hand side. So first we see the hydrogen. There are 3 hydrogens. So H3 now is connected to that carbon, and carbon is connected through a bond to the other carbon. This carbon has 2 hydrogen. Then the second carbon is connected to the third carbon through a bond. The third carbon has 3 hydrogen. So this is the condensed structure. Now how we are going to name it? So this alkane has 3 carbon atoms. So for the 3 carbon atoms, the alk will take the name. Let's go to the table again. In the table, when it's C3, we have prop. So the alk will become prop. So the name will become prop plus and. Prop plus and. Remember, I mentioned in the beginning, and means the carbon-carbon single bond. So the full name for this is propane. Now, there is another formula to represent alkane. That's called the stick formula. And to write the stick formula, you have to see how many carbons are there in the molecule. We have 3 carbon. So to write the stick formula, you put your pen on the paper. When you put that dot is 1 carbon, then 2 carbon, 3 carbon. So we have 1 carbon here, 2 carbon here, the third carbon here, or first carbon, second carbon, third carbon. Now we just do 1, 2, 3. So 3 carbon atom. We don't need to show the carbon. It shows that the corner carbon has 3 hydrogen, the middle carbon has 2 hydrogen, and the corner carbon has 3 hydrogen. But we don't need to show the carbon. When we do like this, that means it's a propane. There is 3 carbon in the structure. This is called the stick formula. And to write the stick formula, you have to jolt or put your pen on the paper, then go up, down, based on how many carbon atoms you have in. So we have done with the alkane with the general formula up to n equals to 3. Like that, we can continue to write the different members of the alkane with n is equal to 4, n equals to 5, n equals to 6, n equals to 7, n equals to 8, n equals to 9, n equals to 10. Please try drawing the structure and naming the alkane with these n values. Try yourself first, and if you feel difficult, then you can further continue watching the video. But I highly recommend you first you try out by yourself, then watch the video so that you can be more familiar to draw and name the alkane. So let's go with n equals to 4. So when we have n equals to 4, the general formula is going to be, as we know, the general formula is CnH2n plus 2. Substitute the value of n here. So it will be C4H, 4 times 2 is 8, 8 plus 2 is 10. So C4H10. So the fourth member alkane is C4H10. And how we are going to draw the expanded structure? To draw the expanded structure, first we have to know how many carbons are there. We have 4 carbons. So connect each carbon with the other through a bond. 1, 2, 3, 4. Says this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. Carbon number 1 already has 1 bond. See, the corner already will have 1 bond. You need 3 more hydrogens so that the carbon can have 4 bonds. The carbon number 2 already has 2 bonds, so you are going to write 2 hydrogen, or put 2 hydrogen for this carbon. For the third carbon, you need 2 more hydrogen. For the fourth, it has only 1 bond, so you need 3 more hydrogen. Now this is the expanded structure of the alkane with general formula C4H10. What is the condensed structure? To write the condensed structure, you start with the corner with the left hand side. So we have H3, then this is a carbon there, CH3, then we have the bond, then we have carbon number 2. Carbon number 2 has 2 hydrogen. Go to the carbon number 3. Carbon number 3 has 2 hydrogen. Then carbon number 4. What is the stick formula? To write the stick formula, we have 4 bonds. So put the point down, your pen on the paper. 1, go up, down, then up. So 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. So this is butane. Remember, you don't need to show the carbon, but if you are confused, we have H3C here, CH2 here, CH2 here, CH3 here. And the name, since it has 4 carbon atom, will go back, and when it is 4 carbon, it's called but plus n, butane. So the fourth member name of alkane is butane. So like this, we can continue with the alkane with carbon number 5, n equals to 6, n equals to 7, n equals to 8. Let me just draw another alkane with n equals to 9. If n equals to 9, the general formula, let me write the general formula again. Will be C, so the general formula is Cn H2n plus 2. So in place of n, we are going to write C9. So this is 2 times n is 9. 2 times 9 is 18. 18 plus 2 is 20. So it will be H20. How I'm going to draw the structure? There are 9 carbon atoms. So connect one carbon to the other. 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, 7 carbon, 8 carbon, 9 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let's name this carbon as carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6, carbon number 7, carbon number 8, carbon number 9. So first carbon is a corner carbon. This carbon 9 is a corner carbon. It has only 1 bond, so we put 3 hydrogen for the first carbon atom. The second carbon already has 2 bonds, so it needs 2 more. The third carbon already has 2 bonds, so it needs 2 more hydrogen so that you can have 4 bonds. Carbon number 4 already has 2 bonds, only 2 are needed. So all the middle carbon or the inside carbon needs 2 hydrogen, but the corner one will need 3 hydrogen. So this is the expanded structure for the alkane with the carbon 9. How write the condensed structure? Start with the left. So H3C, then the middle will be always CH2, CH2 second carbon atom, third carbon atom, CH2 fourth, fifth, sixth, seventh, 1, 2, 3, 4, 5, 6, 7. We can continue like this. Still is considered as straight chain. CH 1, 2, 3, 4, 5, 6, 7, 8, and CH3. Now, how to write the stick formula? There are 9 carbon atoms. So we put up and down. 1, go up, down, up, down, up, down, up. See, 1, 2, 3, 4, 5, 6, 7, 8. 1 more, 9. Now, what is the name of this alkane? So it has 9 carbons. So we go to the table and see when it has the 9 carbon is called non. So the full name is non plus n. It is called nonane. So it's called nonane. Nonane. So like this, today in this we learned about the detailed structure of alkane. What is the general formula of alkane, how we write the individual structure of a given alkane, how we name the alkane. So in the second series of video, we'll be talking about the alkene. Alkene is a hydrocarbon that contains carbon-carbon double bond, and we'll be talking about the alkyne, and if time permits, we'll be also talking about the derivatives of hydrocarbon. So this ends the first series of video, and we will see you in the next series of YouTube video, where I'll be talking about the alkene, alkyne, and if possible about the derivatives of hydrocarbon. If you like the video, please subscribe it, and also press the bell icon and like the video and share this video with your friend so that they can also learn about the organic chemistry. Thank you.